Everybody, so let's talk about the event-driven architecture today. In real life, where we can relate event-driven architecture. So think of your WhatsApp messages or any sort of message app that you use, either Telegram, WhatsApp, Snapchat, whatever messaging app that you use. Let's say when your internet is off, someone has shared a message with you. You don't receive message at that time because your internet is turned off. But when you are back online after a few hours or after a minute or after a day, you will still receive a message from those people who have shared with you when you were offline or when your internet was turned off. So that is what the event-driven architecture is. So even if you send something to the receiver end and the receiver is offline or receiver is not available, but whenever receiver will come back or will be online, at that time your message will be transferred to the receiver side. And this can be done by event-driven architecture. Here we are in the Lucid chart. So there are a couple of diagrams that I have created. We will deep dive into this diagram and we'll understand this complete EDA architecture. Okay, so what we will do, let's start from the scratch. And to understand EDA architecture, let's talk about the request and response model as well. So how request response model works, and every one of us are already aware. When we work with the API, we know, this is the normal behavior. So there is a user, let's say user go to a website, maybe Amazon, that user make an order and that order goes to API in terms of, definitely a request. There are some sort of JSON data would be there. And when API receive the data based on, either it's success or fail, API has to send the response back to the order, right? To the user order. Okay, that is what the request and response model. So what was the problem with this approach, or what is the current problem with this approach? Okay, let's go further and let's take a bigger example as we already did. So let's say there is a user is sitting on some e-commerce website, could be Flipkart, could be Amazon, right? Any e-commerce website where user has placed an order, made a payment, the payment was successful, right? Now on the second hand, there were some microservices involved, which were like notification API that is responsible to send the notifications. There was inventory API. Inventory will store all the related information for the order inventory, and then order API, whatever the order was done, it will store the order information, right? Now let's say when a user made a payment was successful, and after the successful, we have to send request to all those API that was responsible for to hold the user order information, inventory information, and send back notification to the user that your order has been placed and it will be delivered in this date, this time. But due to some server issue or technical glitches, both the APIs, all the APIs actually, all these three APIs were down. So what will happen now? User has already made a payment. So that means there will be no request, or the request will go, but there would some sort of error returned back to the user. That means user has lost the payment because it was deducted from his account, right? If it was just a request and response model, because everything is working directly, tightly. Request has to made and the response will go back to the client application. Request will be made and the response will go back to the client application, right? And when these APIs were down, because the payment was the first step before even reaching out to this API, user has lost his payment. Now to solve this approach, there is a birth of event-driven architecture. So this request was very tightly coupled. This request and response architecture was very tightly coupled. Now let's deep dive into the event driven architecture, right? Okay, to understand event driven architecture, this is the diagram that will help. So over here in event driven, in EDA, people also call it short form EDA, event driven A architecture, EDA. Okay, there are three components. First one is producer, who have to make a request. Second one is broker, right? And third one is consumer. That means producer and consumer will not talk to each other directly. In real life, like buyer and seller, they don't have to talk to each other directly. They have to go through a property broker, right? So there is a property buyer, there is a property seller, and then in the middle there is a property broker. So same concept, event driven architecture. You have producer, in middle you have broker, and then at the consumer end, the destination end, you have consumer. All right. So that is what the event driven architecture is. Now we will try to understand with more detailed diagram. Okay. So let me zoom in, zoom out little so we can understand, and we have the clear visibility of this diagram. Okay, here you go. So now what we have done here, same example. So what we discussed before, this is same, right? Use major request, there are microservices involved, right? But only one change. Before it was direct calls. Here you see, call from here to there, from here to there, from here to there. But now whatever call was made, if the payment was successful, everything will go to a broker, the event driven architecture broker. And that broker is responsible to transfer that JSON payload, that request model, that request data to the consumer, the subscriber, right, to different microservices. So let's say user made a payment and the payment was successful. Then what user will do? Then what our application will do? Application will prepare a list of events, right? We call it messages as well. So it will prepare a list of events. Every events have one name. Let's say if it has to communicate with notifications microservice API, the name is notification underscore send. If it has to communicate with inventory API, then the name is inventory underscore update. If it has to transfer the order to the order API, because we are creating order, so the event name is order underscore create. So all these three events are prepared here, and inside every event there is a proper JSON payload, request payload. So that is sent to the broker, and that would be our messaging queue. So it is stored here, and these three APIs has subscribed to this broker. So whenever there is a message received, these API will get triggered and it will see, okay, I have something related to notification underscore send. It will go and grab that data and will try to process, right? And same for inventory. It will see, okay, I have something for inventory underscore update. Yes, it is there. Okay, let me grab this data. I have to process this data. This is for me. Same for order API. If there is something for order underscore create, okay, this is for me. This is my data. Don't touch anyone, right? And I will process this data. That is how these three microservices API is communicating with broker based on their event naming, event messages. Now let's say same example, the payment was successful, all the data in terms of events, the messages are transferred to the broker, but let's say notification API, inventory API, order API, everything was down, or even one of the API was down. What will happen in this case? So this time we will transfer the message to the user that payment was successful, but even if you noticed, when you are ordering something on the e-commerce website, if the payment is successful, your order is done, but due to some technical glitches, it says pending in the brackets and processing, right? So if you had this implementation event driven architecture, you will display the message to the user on the screen that This is done, but we are waiting for the confirmation. Why? Because there were some technical issues on the server side. Because of that, the APIs are not available and they are not behaving correctly, or maybe they are the offline, right? Now let's say when these APIs are up, so what will happen? As soon these APIs are up, they will go and communicate with this messaging queue, this broker, and they will keep receiving, they will collect all of their events related to their APIs, and they will process, so they don't lose the message. As soon this is processed, definitely the notification API will send that notification back to the user, right, in on their portal or whatever messages or WhatsApp, that your order has been successfully placed, your payment is successfully done, everything. Order database would have their order updated. Inventory API will update in the inventory database for their inventory, and everything is taken care. There is no loss of payment, even though the server was down, or there was some issue on the API side, or there was a deployment in progress, right? So if you have this event-driven architecture, then only you can achieve this sort of feature. And that is why when people work with a big enterprise application, or mainly the finance application, e-commerce application, we have to use the event-driven architecture, not the legacy request and response model. If you have a small application where user audience is not that large, and it's not that critical application, if you don't send back the response back to the user, there is no harm, you don't lose something, then that is fine. We can go with the request response model. But when you work with real application which are enterprise, finance related, or e-commerce, you have bigger audience, you have to make sure you don't lose critical information, especially when it comes to their payments, their money, and go for event-driven architecture. And if I talk about broker, so there are different things that people implement, the developers implement. It could be Azure Service Bus or RabbitMQ. So these are the things, these are the stuff you can implement it as a broker or message queue. Okay, I hope you enjoyed this learning. If you do, please don't forget to subscribe this channel. Okay, all right. That's all for today's video. I will see you in the next